Thank you, Bob, for those opening remarks. Really appreciate it. I think that what we're going to talk about over the next couple of minutes in this fireside chat will kind of round or circulate around those particular topics. Thank you, Dr. Rhew, for joining us. I really appreciate you accommodating us.
My pleasure. Thank you.
No. So we're going to get started with a little bit more of a general question. You know, as was alluded to, today we spend an estimated $1 to $2 billion in approximately 10 to 15 years on drug development. In your experience, what have you started to see that's happening in terms of shortening that timeline or helping, address these challenges that are actually there for companies?
Yeah. First of all, is this mic working here?
There we go.
Whoa. Nope.
Okay, well, this is working. So I'll start with the story. We work very closely with a lot of organizations across the globe that are applying some of the AI, and I think many of these organizations, they've been thinking about AI for as long as we can think about it. AI, the term was first coined in the 1950s. But the reality is the transition of what we used to think of AI with the traditional algorithmic models to now something that is much more powerful, that allows us to be able to leverage these newer capabilities through the neural networks, has given us the opportunity to redefine what's possible. So I think many of you are well aware that when you think about different types of proteins, there are many different receptors, and there's oftentimes a need to model them out. And in the process of modeling these proteins, using the traditional methodology, we've been able to create models in many organizations that are reflective of perhaps maybe a partial fold. And so when we talked to one of the groups that was building this model, and this was about a year ago, they had said that in order for them to apply the existing approach using traditional AI ML and using the supercomputers that they had, that it would take them probably a couple thousand years to be able to create the next version. So probably not something that we would see in our lifetime. Well, in a matter of months, they were able to complete the entire fold modeling using the newer capabilities of AI. And I think this just gives us an idea. It's not just about accelerating the timeline, but it's also about thinking about what was previously not possible is now possible. And I think that's going to give us an opportunity to start thinking about across the board, when we look at things such as drug discovery, and identification of new receptor sites and other areas, there is oftentimes a very manual process that researchers go through. They look at things that they see, they look at what is in the literature and the known identification of others. They look at prior research and they try to then hypothesize, they do this testing, and that process can be greatly accelerated. And that's what we're starting to see on the drug discovery side. And it's happening in pharmaceutical companies, it's happening in startups, and it's happening in academic medical centers across the world. So it is an exciting time. I think we're going to find the opportunities will be revealed once these drugs are actually made available.
Yeah, and I think technology companies such as Microsoft providing a suite of tools that allow for things like process automation, data cleansing, really allow companies to be able to streamline the entire process from data procurement, standardization, actually sending it out for lab result sets, and then coming back and actually getting something tangible for either a researcher to be able to work on or the lab to be able to do experimentation on. How have the tool sets that you've seen evolved over this period of time? Do you find that this is something that is becoming lower and lower as far as the trend line is concerned for the cost associated with everything that we're doing?
So I'll break that into two components. And if you think of AI, think of it as a coin. On one end, you've got the AI itself, which has been incredibly exciting and powerful. But on the other side is the data. And we oftentimes forget that these models that were developed require significant amounts of data, heterogeneous data, and well-curated data. And when we talk about curated data, we're talking about making sure first it's clean, it's accurate, but also have we done the appropriate annotations and all the things that are necessary to make that data useful. The analogy I like to use is, think of AI as an engine that is much more powerful than what we've been doing it before. It's like a sports car engine. It allows us to be able to take us any place. But you need fuel for that engine. And if it's just pure crude oil coming out of the ground, it's not going to work. It has to be purified, it has to be cleaned, and that's literally that process that we're finding is necessary. So you have to do both of those things. And the exciting thing is we're seeing innovations and technological advancements on both sides. AI, I think the thing that has gotten everyone excited is the generative AI. But what we're realizing is that with the generative AI, and to give you an idea of what generative AI is, it's really leveraging the fact that we have neural networks that allow us to be able to understand the relationship between terms and pixels and concepts. And we put greater weighting based on those associations. And with that, we can actually then predict that word, that pixel. Well, generative AI actually does three things really well. It allows us to be able to find things from disparate sources. It allows us to be able to synthesize it into something that's understandable. And then it converts it into the right format for us to be able to utilize it. It could be in the format of a text, like a progress note. It could be in the format of putting it into the right database. But it also could be in the format of writing code that would allow us to be able to do certain things. And so that's what it does really well. And what we're now realizing is that if you just simply said, we're going to use generative AI to solve everything, that's not going to work either. So we're now heading down this path of thinking of what we call multimodal data AI sets, where instead of thinking of AI, generative AI as the only solution, it is a component of the solution. So when you think about what multimodal data AI is essentially different inputs, so like imaging, genomics, and other omics, EHR data, all coming in, and we're creating what's called out-of-the-box embedding models. And so those embedding models are things that allow us to be able to, using traditional AI ML, draw those associations and be able to kind of identify shapes and identify different structures. And then what we do is we use the training data that came from the data sets, and we build those and we train it until it's ultimately fine-tuned on that. And that's what we call adapters. And then the LLM sits on top of that. The LLM allows us to query this multimodal foundation model. So we can, any person, a researcher, a clinician, a patient, can ask this model questions like, can you answer me, like, what is the most likely, or what is the greatest risk of what, this particular event? Can you convert this into a PowerPoint? Can you convert that into, and that's what the LLM does. So think of it as a component within the portfolio of different technologies that can be applied, but requiring clean data.
So on that, we at Tevogen.AI spend a fair amount of engineering power in terms of just sanitizing and creating a novel data set that we actually back up with wet lab science. Are you starting to see a revolution happening in this particular space where novel data sets are kind of dictating how we actually go ahead and proceed forward?
Absolutely.
Any examples would be fantastic.
Yeah. So I think one of the things we know is that if we look at existing data sets, there's a lot of problems with them. First of all, there's redundancies, there's errors, and oftentimes the models we create have problems because of that. But when you're talking about unique data sets, oftentimes you're taking signals from certain mechanisms. So you're using newer sensors, capturing these signals, and with AI, we may be able to then translate those signals into something that is much more accurate, has high fidelity. So I'll give you an example. So at Microsoft, one of the things that we recognized was that voice is a signal. So when a person speaks, we can take that signal and we can use the technologies to identify from the voice what the words are, and then use traditional AI ML to codify in the back end the terminologies. And then what we could do is we could actually convert this into a clinical progress note. And that's what we have with something called ambient clinical intelligence. It's an extraordinary technology because it's saving doctors and clinicians at least 50% of the time required to document to EHRs. So in terms of making things more efficient, we have a mechanism to be able to take that raw conversation and remove that element which required a clinician, which was listening to it, understanding it, putting it into a note, and then ultimately entering it to the EHR. And that middle process has now been automated. And so that's one of the really exciting things. We are now finding whether it's a signal from the voice, whether it's from an image, whether it's from a genomic profile, whether it's signals from the biochemicals, so many great opportunities.
It brings to light one of the examples that I actually had where somebody was using this in terms of psychiatric patient engagement, where they were going ahead and using an app so the psychiatrist can continue interaction between sessions that are actually present by just doing simple interactions. You have signal data that are being captured by your devices, by watches, etc. It really kind of pushes the envelope of what we can deliver in terms of patient care. Speaking of patient care and what AI is really allowing us to do, where it's allowing us to process these significantly large data sets now and understand it across swaths of different patient populations, I feel like there's a revolution that's coming in terms of the precision medicine as well, and what AI can actually go ahead and deliver in this particular regard. What are you starting to see as far as a trend is concerned in this? And I think that you're speaking at an upcoming event about this, right?
That's right. So I think we all agree that if the medicines can be made specific for the individual, you're going to get a better outcome.
Yeah.
And what we have relied on are the patient history to kind of give us that. But we now have mechanisms to be able to get even more specific, in particular your genomic profile. But of course, there's a whole series of other types of signals that the person can be providing. They could be providing other types of biochemical signals. They could be providing imaging signals. And the more that we can take those different sources and put them into a common structure and understand how we can draw conclusions from that, allows us to be able to become much more precise. And I think that's the reason why when we talk about precision medicine, it's not just about your genes, but it's about all those different elements and how we can then pull them together. What we have found is that there are certain, I'll call it modalities that tend to oftentimes be very important. Imaging is obviously a very important one. EHR data and genomics. And those three are very large in their data sets, very complicated, and there's multiple variations that we can see. That's the reason why we need very large data sets. And oftentimes what we find is that organizations that have those data sets are populating them with these others so you can understand context. And the other thing that I think that we've come to realize is that data, if it's just simply a snapshot of what you're capturing at one point, that's not as valuable as longitudinal data. Understanding the progression over time, having an understanding the impact that treatments have on outcomes, that's what allows us to be able to make those conclusions as to whether or not these treatments are having an effect or not. And if you just have that one snapshot, it's not going to give us as much information.
Yeah. No, and on that point, I think there was a lot of governmental agencies in especially foreign countries, Belgium, London, come to mind, where they've actually allowed people to volunteer their information in making it available for genomic research, which is a great program because if you have some organizations that are actually going ahead and structuring the information in a format that is universally understood, then you give the opportunity for different biotech companies to actually go ahead and produce something against it. But that also brings a separate part of the equation, which is the responsible development of all this, right? You don't want underrepresentation in any of this. In my opinion, I feel like predictive AI really helps fill the gap in some of these situations because it's not every country can necessarily afford a program such as that because just to house that information is very costly. Any insights into responsible development?
So let's kind of talk about two different aspects to this. One, there are a lot of questions and concerns about data privacy.
Yes.
And so data privacy has to be understood in the context of, are you securing the data, but who has access to it and for what purpose, and how do we ensure that we can continue to collaborate? Because if you just simply took the perspective, we need to secure all the data, you'll never be able to learn from it because a lot of the AI and the others are coming from third parties. So what we've been finding is that we oftentimes need to sort of redefine what we do for collaboration. Traditionally, it's send your data sets to the central area, and then from within that central area, trust us, we're going to manage it, but if there's a data breach, you're responsible. I mean, that's not a great business model for a lot of folks, and so there's resistance to doing that. What we've now found is that rather than just sending everything over, think of it as a decentralized approach where it's federated learning. You'll bring the models to the data, so you don't have to worry about the data somehow getting out to some other area. But if you're going to do that, there's one other thing that you have to do. You have to make sure that the models themselves are protected. Because if you're a third-party IP, your IP is now exposed if you bring this in. So we've been looking at something called confidential compute and privacy preserving environments, which allow you to be able to then have total confidence that both the data and the IP are preserved. And what it does is it runs the analysis, it spits out the outputs, and neither the data or the IP ever get exposed. It allows us to be able to enable what they call data collaboration without data sharing. And that's a different concept, but it allows us to be able to progress and do things which will advance innovation. So that's on the data side. But on the I'll call it the more process-oriented side, there are many principles that have to be adhered to. So there's principles of transparency, principles of bias mitigation, making sure that you can provide value and return on investment. So like all these fall under the category of responsible AI. And what we've realized is that organizations today that want to implement responsible AI oftentimes run into the problem that it requires time, resources. So they are at the point where they're saying, well, we want to do it, but how can we do it because we're stretched in terms of bandwidth. And this is where organizations like the Trustworthy and Responsible AI Network, which is an organization that at Microsoft, myself and several others have been working with health systems to figure out ways that we can reduce the cost, time, and resources required to implement responsible AI. So 3 ways. One is technology itself will make things more efficient. The second is collaboration between health systems in privacy-preserving federated manners so that you can actually share and distribute the workload for testing and monitoring, because testing and monitoring will actually probably be 2 of the biggest challenges that we see. And the third will be technology companies coming in to provide mechanisms where they can offset some of the costs associated with testing and monitoring of their models on these local data sets. So these are all kind of things that are in play, but responsible AI is a shared responsibility. It's not just technology providers, not just providers, it's really all of us.
Thank you for that, and thank you for your time. I know that we're run short as you have to go to another panel. So I thank companies like Microsoft for actually going ahead and introducing concepts such as confidential compute, and I'm very excited to be working with a company such as Microsoft to further progress our Tevogen.AI story as well. Appreciate your time.
It's been my pleasure. Thank you very much.